It says we're going live, and we're now live. Okay? I want you to know you're my only class that actually cares about thumbnails, so.
We care about
All right, so we're doing equations in two variables. Okay, so just remember, those logarithms that you thought were so hard, they're going to be on your test on Thursday. So this one hopefully will not be too bad.
Are we going to do the crazy ones like the squirrel population?
Yeah, we'll probably do the squirrel population too.
Oh boy. What's the number?
What's the number? Oh, this is chapter, this is 5.1. 5.1 that we're covering. So this is two variables, okay? So if I have two equations, do you guys know how to solve this?
Yes.
Oh, you're not on.
Oh, not on? Oh, it's crooked. Thank you for being my camera. Gosh, that is bright, it's hard to see. Okay, there we go. Yes, Bailey, you're gonna be my first one because you like to be the first, to get these questions, right?
Okay,
How do you solve this?
we're trying to solve it, but we want to solve for, get two variables that are the opposite of each other, so we multiply one of them by a negative number, so like the y's will cancel out and we'll get the x.
Okay, so there's two ways to solve. So you have two equations, two unknowns, two ways to solve. So there's the method you're describing is elimination, which you certainly can do and is usually the easier method. But there might be an easier one on this one, which is substitution. Why would substitution possibly be easier?
You got really basic numbers.
You can get a y equals all by itself, right? Okay, so if I subtract 2x from both sides, then I'm going to get y equals 1 minus 2x, correct? Okay, do you want to take it away, Spencer, since you've got the substitution down?
Sure.
Okay, so we're going to substitute this where?
So we're going to plug that into y on the bottom
Right
equation.
there. Okay, so we're going to get
It's going to be 4 minus.
3x.
Oh, that's a 3?
Oh, that's a 3. Doesn't that look like a 3?
I thought we're plugging it in for y.
We are.
Oh,
I still have that
sorry.
3x. I can't forget about it.
3x plus 4
Plus 4
minus
times.
8x.
Oh, you distributed it. I'm going slow.
Okay.
Okay, we're just substituting that in there. Okay? All right, and then you already did this. This becomes 4 minus 8x plus 3x equals 14. And then what?
Then we're going to solve for that if we can. So combine like terms, we have minus 5x plus 4 equals 14. Subtract 4, bring us to minus 5x equals 10. And then divide by negative 5, bringing us to negative 2. X equals negative 2.
X equals negative 2. Now, we're going to find the y. How do I find the y?
Plug it back into the
Plug
original.
it back into my original substitution because I got a y equals here, right? So I'm going to get y equals
1 minus 2 times negative 2, which is just going to be positive 4.
4 plus 1 is 5. So 5 equals y. Okay? Welcome back. All right, does that make sense? Okay? So the thing is, I liked Bailey's solution there. Elimination is usually good, but if you have one letter all by itself, sometimes that's easier. Okay? All right, let's do another one. In fact, we'll keep it easy for now. What if I had 3x plus 2y equals 14 and x minus 2y equals 2? So I'll pick on Bailey because this is what she wanted to do in the first place, right?
Both of the y's.
So the y's clearly cancel if I add them, right? And then what? So if I add these together, I'm going to get 4x equals 16. Divided by 4x equals 4. Okay. Now how do I find my y?
We just plug in or to any of the equations.
Either of
so
the equations, which ones do you want to do?
we'll do the one on the bottom.
One on the bottom. So 4 minus 2 times y equals 2.
So then subtract the 4.
Subtract the 4's.
And that's negative 2y
Negative 2y equals what?
-2.
Negative 2.
Then divide by -2, and then you get y equals 1.
Y equals 1. Okay? So there we are. Okay? All right, piece of cake. Is it better than logarithms?
Yeah. Oh,
Heck
it
yeah.
starts getting way harder.
It does start getting way
I
harder.
actually did this last year.
Yeah, you know, they actually call this linear algebra. We're going to learn some linear algebra. They actually have a whole class on just plain old linear algebra. It's awesome. And then when you get into statistics, then you can do it on like 20 equations and 20 unknowns. Yeah, that's what I'm talking about. Okay? All right.
I think we get joy out of different things, and you get joy.
Okay, so how about let's just go with this one. 3x minus y equals 0, and 5x plus 2y equals 22. Okay? So, it must be Cameron's turn. No?
Yeah, okay. So could we subtract the top equation from the bottom equation?
You could, but I'd like to eliminate something, and if I just add or subtract them, that doesn't eliminate anything.
Okay.
What could I do to, would the y's or the x's be easier to eliminate?
The y.
The y's, right? All I would have to do with the first equation is multiply the whole thing by 2. So if I multiply the whole thing by 2, this becomes 6x
minus 2y
minus 2y
equals 0.
0. Okay, so now those are going to go away, correct?
Yeah.
Okay, and I'm going to get what?
X. Or, sorry, x. Yeah.
No, you're going to get 11x. 5 and 6 is 11, right? We're adding them?
Oh, we're adding them. Sorry.
Yeah, because these are added too, right?
Yeah.
Okay,
11x, those two cancel, and then that
equals
equals 22.
22,
Divided by 11,
x equals
2.
2. Okay, now how do we get the y?
You just plug the x back in.
Okay, which one?
Whichever one, right?
Yeah, I'd probably go with the top one, but you could plug it into either one theoretically. Okay, so which one do you want to plug it into? Top one, we're gonna get. Cameron's not done yet.
Oh, I'm not done?
No.
So you're gonna get 6 minus y equals 0.
So 3 times 2 minus y equals 0, so that's 6, so I can subtract 6, right?
Yeah.
So negative y equals
-6.
negative 6,
Divided by negative.
divided by negative 1, y equals 6. Okay? These are a lot better than logarithms. Just said logarithms for the last week. Of course, then now you can say, oh, I'm through the hard stuff. Except for you're going to have logarithms on this next test. It'll be
Say that
fun.
again?
Oh. I said it's going to be fun now that we've got the logarithms almost over with, right?
Are we gonna add this?
Are we gonna ever get these with logs in them?
No.
No.
I'm not that mean.
I think you are.
That mean. Okay. How about this one? 8x minus 2y equals 5, and negative 12x plus 3y equals 7. Okay? So, whose turn is it? Berkeley, it must be your turn.
Okay, there's 2 ways you can probably do it.
Okay?
Would you find the greatest common factor between 2 and 3?
Yeah, so the way I like to think about it is, do you think the x's or the y's would be easier to eliminate?
Probably the y's.
Probably the y's in this case, right? So what would I have to do the first equation to
Times the first one by 3.
3 and the second one by
2.
2, okay? So the top equation becomes,
8 times 3, which is, I can't do math right now.
24, I got you.
24
24x
minus
minus
6y
6y
equals 15.
15
And then negative 24x plus 6, negative 6, or plus 6y.
plus 6y equals 14. Oh, wow. Didn't mean to eliminate both of them, did we?
That's what we do on that one.
But we eliminated these, we eliminated those, so we're gonna get 0 equals,
1. Illegal.
doesn't equal 1.
29.
So 29.
Uh,
When is that true? Only when I owe you money, right? Okay? So what does this mean?
illegal.
Illegal is not the correct answer, but it's close. You're on the right track. What'd you say? Undefined? Undefined, I'm not really looking for. No solution. No solution, that's what I'm looking for. Okay? Now, let me ask you a question. What if I had gotten, instead of 0 equals 29, 0 equals 0?
It
That's
can be
undefined,
anything.
right?
Then we have an infinite number of solutions, right? And what would we call it?
All real numbers?
Well, not all real numbers. You have infinite solutions, but that doesn't mean you can just put anything in there. Okay? If I get a 0 equals 0, here's what I want you to write on your paper. It's dependent. Okay? Now, I have a feeling in the book they have some weird x such that blah, blah, blah. It's weird. All I care about is I want you to be able to distinguish whether there's no solution or whether it's dependent. Usually, like an easy way to do a dependent solution, if I had 2x plus 3y equals 5, and if I had 4x plus 6y equals 10, do you see that those are basically the same equation? Okay. So this is really, this equation here is dependent on the first one. It's just the same thing times 2, right? Okay?
So it's 0.
So in this case, this is an example of a dependent situation. This is an example of no solution. Okay? Essentially what happens with no solution,
But wouldn't that
No solution, we're gonna get to 0.
means you're gonna have parallel lines. They never cross. Whereas for dependent, essentially you've got 2 lines that are exactly on top of each other. It's the same line. It's the same line twice, which is multiplied by 2.
But when you
In most of these other cases, it was off there, so you can see that. In these other cases over here, essentially what we're saying here, you've got 2 lines that cross, and in this case, they cross at -2, +5. 1, 2, 3, 4, 5. I don't know what the lines look like, but they cross. Okay, you could graph them, but the idea is that they cross at this place, and this is the solution to -2, 5. Or 1, 4. Maybe they cross 1, 2, 3, 4. Maybe they cross like this or something. I don't know. We could graph it and prove it. But the idea here is we're trying to find where's the place that they cross. These never cross. These cross all the time. Okay, does that make sense? Sorry, you didn't get to see what I was pointing at there. Okay. All right. Oh, these are fun. These are fun. You guys like it when I say that, right?
Love it.
Okay. All right. So here we go. A woman rows boat upstream to a point 4 miles away. The return, oh, sorry, I forgot a piece there. 4 miles away in 1.5 hours. The return trip takes just 45 minutes. How fast does she row? How fast is the current? Okay? Angel, what do you think? Any ideas?
Let's see. So to equal 4 miles, take 1.5 H.
Okay, so you might be on the right track, but I want to slow down. I want to tell you, you guys all remember that rate times time equals distance. You guys agree with that?
Yeah.
You've heard of that before? No? No, you have. So rate times time equals distance. Okay? So we know that she's gonna, so if this is my river here, so, and if she's going this way, this is upstream, right? The current, is the current gonna help her or hurt her upstream? Hurt. It's gonna hurt her. So her rate going upstream is going to be whatever her rate is in still water minus the current, correct? And downstream, the current's gonna help her, right? So this is upstream. Downstream, it's gonna be whatever her rate is plus the current, correct? So I don't know what the rate or the current is, but I know that her rate times the time. So let's see, upstream, here, I'll put this here. And that one. How long does it take her to go upstream? An hour and a half, right? 1.5 hours. That's going to equal a distance of 4 miles.
Would it be better to convert it to minutes?
Well, that was what I was just going to ask. Okay. You're either going to have to either go all minutes or all hours. Which would you rather do?
Hours, do minutes.
Well, either way, it'll work either way. But do you see that 45 minutes is 0.75 hours? If you want to go 45 and 90, it'll work. You don't like decimals? Okay. So are we good otherwise? And she's still going 4 miles, correct? Okay. So does that make sense so far? Okay. So I'm using rate times time equals distance. I've got her upstream and her downstream. It would be awfully nice if we could cancel those, but we've got to multiply those by the factor, correct?
Yep.
Okay, so I've just come up with the two equations based on rate times time equals distance. So, Angel, how would I solve it from there?
So you distribute in times.
Okay, so we'll distribute this in. So this becomes 1.5R minus 1.5C equals 4 miles, right? And this becomes 0.75R plus 0.75C equals 4 miles.
So you can either multiply the bottom one by 2 or divide the top one by 2 if you wanted to do this addition, subtraction method. Or you can
Which one do you want to do?
and yeah, let's do that one.
You want it, so we're gonna multiply the bottom by 2?
Yeah.
Okay, so that's gonna become 1.5R plus 1.5C equals 8. So this is no longer here, correct? Now what?
So then we just add them.
Add them up, right? Because these are gonna go away. So 1.5 plus 1.5 is 3R equals 12. Divided by 3. So her rate is 4 miles per hour, correct? Miles per hour. And how fast is the current?
Plug it
Plug it into what?
in, down to either.
Either one. Which one?
Let's do the plus.
The plus. This one? This one here? This one here? This one here? Yeah, top one. Keep it simple. 1.5 times 4 minus 1.5 times C equals 4. 1.5 times 4 is 6. I'm going to subtract 6. Negative 1.5 times the current equals negative 2. Divide by negative 1.5. So C equals 2 divided by 1.5. What is that?
1.4 or 1.25.
I don't know that one. Oh, I closed my thing. What is it? 2 divided by 1.5. 1.33 miles per hour. Okay? That makes sense? You want 10 of those on the test?
Nope.
Yeah,
That wouldn't be there.
Yeah,
If you can guarantee.
10 of these and no logs?
Yeah.
If it's gonna be 10 of those, you can call it now, we can study it more.
Yeah.
Just study
Yeah, it will be 10 of these.
For tomorrow's quiz, it's like 20 of us.
You have to do it in fact amount of time.
Just keep on, just pass it out.
It's all about
Gosh, that was
numbers.
easy.
Yeah, just read the numbers. Right.
All right, well, we're done with 5.1. Let's move on to 5.2. Okay, that was way easy. I think 5.2 will take a little more time, so that's good. That was 5.1. We're moving on to 5.2, which is 3 variables, 3 unknowns. Okay, so the same rules apply that we just used here. Oh, we're going to start with a nice, easy one. X minus 2y minus z equals 1. Y plus 2z equals 5. And z equals 3.
Is this given?
This is given to us. So, Julia, must be your turn.
Okay, does that middle one say y plus 27?
2z, that's a z.
Yeah.
Okay, so z equals 3, that was easy.
Yeah. Oh, I like that.
Then what?
And then, well, can you plug that into the other?
Plug that into the second equation, and I'm going to get
Okay, y plus 2 times 3.
2 times 3 equals 5. This is 6, right? So I'm going to subtract
Yeah, subtract that.
6. Y equals
Negative 1.
-1. And
And then just plug
both of those back in the first one. X minus 2 times
2 times -1.
-1 minus z
3.
equals 1. Negative 2 times -1,
2.
positive 2 minus 3,
-1.
-1, so I want to add 1 to both sides. So we get x equals 2. Okay? That was easy. You want more of those, Dino, right?
I'll get another 10 of those.
10 of those, please.
10 of those?
Did that go?
I'll probably have to give you 20 of those. All right, here we go. How about x minus, I guess I better turn this off. X minus 2y plus 3z equals 1. X plus 2y minus z equals 13. 3x plus 2y minus 5z equals 3. Okay? All right, so, Dino, it must be your turn. What do you think? Any ideas how to do this one?
I mean, I would take the middle equation and just try to get it x.
Okay, so the idea of 3 equations, 3 unknowns, I want to eliminate a variable. So I think what you said, but just let me make sure I'm clear on that. You can eliminate the x's, the y's, or the z's. I think you said the y's. Is that the letter you're trying to eliminate? Sure? I thought that's what you said. Okay? So did you want to take these 2 equations here and eliminate the y's? Okay. So we're going to add those 2 equations together, correct? So if I go x plus x, I'm going to pick another color, I'm going to get what? 2x. The y's are going to go away. 3z minus z is plus 2z equals 1 plus 13 is 14. Okay. So now we've eliminated the y. So we need to eliminate the y again using 2 different equations. How can I eliminate y again using 2 different equations? The top and the bottom one, right? So if I take the top and the bottom one here, the y's are going to go away again. Okay? So x plus 3x is 4x. The y's go away. 3z minus 5z, 2z. Oh, you looked at on that one. 1 and 3, 4. Now, what letter would be the next one to eliminate? The z. You really lucked out on that one because those z's are going to go right away. 2x and 4x is 6x. 14 plus 4, 18. Then divide by 6. X equals 3. Now what?
Now you put x into one of those equations.
One of these 2 equations, which one?
Whichever one you want.
Whichever one you want. Which one do you want? The bottom one? Okay, we're going to plug 3 into the bottom equation. 4 times 3 minus 2z equals 4. So I'm going to subtract 12. Negative 2z equals 4 minus 12, which is negative 8. Divide by negative 2. Z equals positive 4. Don't mess up your signs now.
Oh, sorry.
Okay. Was the screen blocking it? Okay. So z equals 4, then what? One of the top equations, right? Which one? The second one?
Yeah.
Okay, so x is 3 plus 2y minus z minus 4 equals 13. So 3 minus 4, negative 1. So I'm going to add 1 to both sides. And we get 2y equals 14 divided by 2. Y equals 7. Now, theoretically, you should check your answers.
That's a ton of work.
We'll let Andrew do that.
Uh,
Okay? So that was a good one.
you gotta get
Okay, should we keep going on that? All right. Okay, let's do another one. Make sure you guys are good on this.
I'm not, let me show you.
You're not?
Just because I haven't. Yeah. Got this. That'd be 2x. Should be the z. So 2x.
All righty. How about x plus 2y minus 2z equals 1, 2x plus 2y minus z equals 6, 3x plus 4y minus 3z equals 5. Okay? Hunter, you look like you want to do this one. Okay, what looks easiest to eliminate? The x, the y, or the z? The z? Okay. So which two equations do you want to use to eliminate the first z?
First two.
The top two, okay. So how do I eliminate a z with the top two equations? So we're going to multiply this one by -2, and then that will make the z's go away, right? Okay, so this becomes -4x
Minus 4y.
minus 4y
Plus 2z.
plus 2z equals -12, and then I'm just going to rewrite this one, okay? X plus 2y minus 2z equals 1. Okay? So the z's go away. -4x plus x, -3x. -4y plus 2y is -2y equals -11. Question?
No, we're still on the last problem.
You're still
We're
on?
just trying to decipher after you did it, because. Yeah, so the bottom two, so we understand you added the top
Okay.
equation to the middle equation to get that first 2x, but then you added the top one with the bottom one, not the.
Yes, the first time we added the top two equations together to get this. Then we added the top and the bottom equation to get this.
Okay, that makes more sense.
Okay.
For some reason, we were doing the middle and bottom one, and we couldn't figure out how you got the answer you did.
Oh, that's
but
why
that makes sense.
I tried to draw these brackets for the first one and then the purple brackets for the second one. Yeah.
You're good.
Okay?
We understand that.
All right. Okay, coming back here. Okay, back to our problem. Okay, so I've used the first two equations to eliminate the z variable. I have to eliminate the z variable again using two different equations. So what would be better this time? So I need to eliminate the z again with two different equations. Middle and the bottom, right? I can take both of these two here. So how can I eliminate the z's with these two?
Times by -3.
Instead, now I'm going to times by -3, right? Do you see that? Okay, so then this becomes, I'm going to write this over here, I think. So this becomes
-6x.
-6x
-6y.
minus 6y
Positive 3z.
plus 3z equals
-18.
-18. Okay, and then I'm just going to rewrite this again. 3x plus 4y minus 3z equals 5. I'm going to add those together. The z's are going to go away. -6x plus 3x,
-3x.
-3x. -6y plus 4, -2y equals -13, right?
Yeah.
So I'm going to rewrite that down here. negative 3x minus 2y equals negative 13. Okay. What do you notice?
It's illegal.
That's the same equation twice, right? Except for these are not the same.
No solution.
So I could subtract them and I get 0 equals 2. But, is that a true statement? So therefore, unless I owe you money, he even said it, that was good. So therefore, the answer is?
No solution.
No solution. Does that make you excited that you got that with the problem early?
Yes.
Do you want 10 of those?
Yeah.
Sure.
Okay. Beat those logarithms, right? All right, how about,
I understand for the first two, you do these two, you use these two, so these two. These two together, you positive and zero, and then there's like one, and therefore you.
all right, let's do another one. Okay, here, let's see here. X minus y plus 5z equals negative 2. 2x plus y plus 4z equals 2. And 2x plus 4y minus 2z equals 8. Okay. Here, just a second. All right, they're doing this in a different order than I would have expected. All right, so Andrew, it must be your turn.
Yes. Indeed.
So what letter do you think is easiest to eliminate?
I'm guessing X
Probably the x's, right?
for sure.
Okay, so which two equations do you want to use to eliminate the x?
Let's do the top one and the middle one.
Top one and the middle one, okay? So I would need to multiply the top one by 2 or negative 2?
Negative 2.
Probably negative 2, right?
You're awake. Yep.
Okay, so if I multiply by negative 2, I'm going to get
You're going to negative 2x.
negative 2x
Plus 2y.
plus 2y
Minus 10x.
minus 10z
Z, my bad.
equals,
Plus 4.
okay, and I'm just going to rewrite the second equation, 2x plus y plus 4z equals 2. Okay, we're going to add those, the x's are going to go away.
3y.
3y,
6z.
6z equals
6.
6, okay? Now we have to eliminate the x's again using which two different equations?
Let's do middle one and the bottom one.
Yeah, we could actually just subtract them this time, right? Okay, so if we take the top one minus the bottom one, the x's are going to go away.
Yep.
Y minus 4y,
It's 3y.
negative 3y.
Yep.
4z minus negative 2z
Is 2.
plus 6z. We're subtracting, right?
Yeah.
Okay. 2 minus 8,
6.
negative 6. Ooh, what happened?
Dependent.
Those go away, those go away, those go away. I get 0 equals 0, which means,
And then
it's a good thing you had all those whispers. Would you have known that without all those whispers? For sure. Okay?
Yeah, since there's 3 functions, if 2 of them happen to be in parallel, it's all dependent.
Well, it's hard to say. The easiest way is, are you going to get a true statement or are you going to get a false statement? I said those in the
Not
middle.
the other way around.
Does that speak for the
So
whole?
if it's a false statement, it's no solution. If it's a true statement, it's dependent. Yeah, so basically, these are parallel.
All three?
I don't know. It's hard to graph in 3 dimensions, and it's hard to think that way too.
Yes.
But essentially, yeah, we've got some parallel lines. Okay? Now, by the way, in the back of your book, it's going to say X such that, and it's going to list out an equation or something weird. All I care is it's dependent. That's good enough for me. Okay? At least I think that's what the last book did. Well, the weird thing is, we're done a little bit early, but I know that section 5.3 is really long and really hard. So what I would, and it's related to what we're doing here today. So what I would like to do, we'll probably only get through maybe half of 5.3. I think we'll get through as much as we can. The quiz, here's what I will say. The quiz tomorrow will be only on 5.1 and 5.2. And then, but this will help us speed us up a little bit for tomorrow. So I won't make you do 5.3 tomorrow, but it's related really closely to what we're doing today. And we'll try to do the easy ones today and the hard ones tomorrow. Okay? So I would like to keep going. And then, you know what would be nice? Would you guys like a whole week to review everything at the end of the semester?
Yeah.
I haven't decided if we're going to have 6 or 7 tests. If we get done a little early, we might have only 6, and then we'll spend the last week just reviewing.
I want 7 tests.
So
7 tests will help.
Yeah.
Exactly.
That's
a thumbs up for me.
Or we could just do like a review test.
Or a review test, close up the grade, then we got the real test.
So
All right, well, we'll see.
that.
All right, let's see here. All right, so 5.3. 5.3 is partial fractions. Okay? And we're going to have 4 cases. Case number 1 is linear partial fractions. Case number 1 is only linear factors. Okay, there's actually going to be 4 cases that we're going to go over here. And just remind me again, who's taking calculus? 1, 2, 3, 4. This is, I think, one of their favorite this and logarithms are their favorite sections in calculus. Okay? All right, so the idea here is, let me see if I can give you a nice, oh wow, okay. So the idea here is, if I had 1/2 plus 1/3, how would you solve those? Let's just do a nice simple case. Common denominator, which would be
3/6.
yeah, I'd multiply this by 2/2 and this by 3/3, and I would get 3 plus 2/6, which equals 5/6. Correct? Okay, so the idea here is, with partial fractions, what if I gave you the answer? So this is kind of like Jeopardy. I'm going to give you the answer. You need to come up with the 2 original partial fractions.
Oh, so it's kind of like.
So we're kind of like
when
working
you
backwards.
factor, kind
Say it again?
It's kind of what you do when you factor, like, oh.
Yeah, kind of. And so the idea is we're going to be working from the answer and we're trying to get back to these two original fractions, okay? But we're not going to do it on little simple numbers like this. We're going to put a lot of x's in there, okay? So here's what we're going to do. Let's do our first example here, okay? So I say, I want you to find the partial fractions of 5x plus 7 over x cubed minus 2x squared minus x minus 2. Okay, so the idea here, well, let's do this first one. We might only get through one case today. That'll probably be true anyway. Okay, so Caitlin, do you think you might be able to factor this maybe by grouping? I'll give you a little
Yeah,
hint there.
yeah, so the bottom you factor by grouping.
Okay, so I can
you pull out
pull x squared, and I'm left with
x minus 2.
x minus 2, and I could pull out a negative 1.
And then it'd just be x minus 2.
Oh, did I write this wrong? I think I did.
Yeah.
So then
This should be a plus.
Oh, it should be plus.
Okay, and so now
I was like, oh, this is easy.
this is x minus 2. Wait, did I write it down right? Plus, yeah. And so then this would become x plus 2 and x plus 2. Helps if you write the problem down right.
Okay. So then it's just x plus 2, and then there's another bracket with the x squared minus 1. So it's x squared minus 1.
X squared minus 1 times x
there we
plus
go.
2. And then this factors again.
And it's x plus minus 1.
X plus 1, x minus 1, and then I have my x plus 2. Okay?
Yeah.
And we didn't even need to use synthetic division on that. Wasn't that nice? Oh,
Lovely.
by the way, guess what? Don't forget that.
Okay.
I'll probably have to put it back on the test again, just to make sure. Okay, so you can see that this bottom here factors into these. These are all linear factors, correct? They all have a degree of 1, correct?
Yeah.
Okay? So the idea here is this is case number 1. We only have linear factors, okay? So what I'm going to do is I'm going to take this equation here, and I'm going to break it up into 3 fractions, okay? One fraction is going to have x plus 1 as a denominator. Another one's going to have x minus 1 as a denominator. Another one's going to have x plus 2. Okay, does that make sense so far?
Yeah.
And we're going to add them together. And I don't know what's going to be in here, so I'm just going to put the letter A, and the letter B, and the letter C. Okay? Now the idea, just like we were talking about here, we're starting with 5, 6. I want to go back to here, okay? So I need to get a common denominator. Okay, what's the common denominator? What we started with, right? Okay, the common denominator is going to be x cubed plus 2x squared minus x minus 2. Okay? Now, the question is, I'm going to move this over a little bit. What do I need to multiply this by to get that?
The denominator of
X squared.
So I'm going to need the other 2 factors. Correct? So I'm going to need an x minus 1, and I'm also going to need an x plus 2. Okay?
So then that's the new
X plus 2, x minus 1. Does that make sense?
Yeah.
Okay? Now the question is, I move this plus over here. What do I need to multiply this by to get this? This one here and this one here, correct? Okay? So I'm going to have an x plus 1, and I'm also going to have an x plus 2.
Could you use synthetic division for that? Or just division, like long division? This is.
I don't know why you'd want to use long division.
Because it's a fraction. Because 5x plus 7 divided by. Could you do that?
We'll worry about the 5x plus 7 later.
Okay.
Okay? All right, now the question is, what do I got to multiply x plus 2 by in order to get
It's the other
Plus
two.
one.
So
the other two here. I'll pull out
x
another
plus
color, black. So I got to multiply the x plus 2, so I got to do these two here, correct? So I got to multiply this by x plus 1 and x minus 1. X plus 1, x minus 1. You with me so far?
Yeah.
I'm glad we started this today. This will take forever tomorrow. Okay? All right, so now, okay, let's FOIL this. Okay? This becomes what, Caitlin? If I just FOIL this.
So if you just FOIL that,
Just the two purples.
it becomes
X squared.
X squared
plus 2.
2x
Yeah, 2x.
minus x
um,
minus 2
plus-
all times a, correct?
Sure. So it's X squared plus X.
Yeah, you guys are going to like this. The last two sections were so easy, and now you're going to be like, oh.
Yeah.
Okay, so are you with me so far?
Yeah.
Now we're doing each
It's
one.
like-
The 2x and the x comes to a regular x, correct?
Yeah.
Okay, now, I need to multiply x plus 1 times x plus 2. So I'm going to put b times
X squared plus 3x plus 2.
x squared plus 3x plus 2 plus c times
X squared.
x squared
Minus 1.
minus 1. Okay, so at this point we've got a common denominator, and I'm not going to worry about writing it every time. I'm focused more on the numerator now. So I'm going to distribute my a through, and I'm going to have ax squared plus ax minus 2a. Are you with me so far?
How do you
Yeah.
Ax squared, a times x.
Yeah.
Okay. Now I'm going to distribute the b, and I'm going to get bx squared plus 3bx plus 2b. And then I'm going to distribute the c, and I'm going to get cx squared minus c. All over, and I'm going to put d for the denominator because I don't want to keep writing it. I don't need it anymore. Okay? Are you with me so far? Okay?
then you can
All right,
like-
now, remember, we originally started with 5x plus 7. You've probably been wondering why we've been ignoring that for so long. Okay, we're not ignoring it anymore. Now, the idea here is I could also, if I wanted to, write a 0x squared, correct?
Yeah.
I haven't changed anything, it's just a 0, right? Normally we wouldn't do that. But the reason I'm going to do that is I'm going to take all of your x squared terms. 1, 2, 3. Okay? So all of the x squared terms have to equal 0x squared. Okay? So I'm going to take your a plus your b plus your c has to equal what?
0.
0. I just heard it groan. Okay, now let's take all of your x terms. So I've got that one, I've got this one, that's it. Okay, only got 2 x terms. Okay, so a plus 3b has to equal
0.
5. Okay, and now my constant terms, negative 2a.
Can you move the camera?
Oh, thank you, sorry. Negative 2a plus 2b minus c has to equal
7.
7. 3 equations, 3 unknowns.
Oh, that's easy.
Now we just get to keep doing what we've been doing with section 2, correct?
That is cool.
And you wondered why we wanted to do this. This is a perfect example. And you will need to do this in calculus. Now, notice one of my variables is already eliminated, and these two look like they'll be easy to eliminate the c again, correct? So I'm going to rewrite a plus 3b over here. Give myself some room here. Okay, so I'm going to rewrite that middle equation. A plus 3b equals 5. Okay, so I've just rewritten this. Now we're going to add these two because the c's are going to go away. And whose turn is it? Dino. I already picked on Dino. It must be Jonathan's turn. Can you add those two equations together and help me write the answer over here? So a minus 2a is negative a. B plus 2b is 3b equals 0 and 7. 7. This was really, you guys are lucking out on this thing, okay? Now, Jonathan, can you take it away from here?
A's cancel.
The a's cancel.
6b.
6b equals
13.
12, actually. And then
Then divided by 6, so b equals 2.
b equals 2. Okay, if b equals 2, which one do you want to plug it into?
The top one.
Top one, a plus 3 times 2 equals 5. 3 times 2 is 6, so subtract 6. A equals negative 1. Now what?
Plug that into
I need to plug it in back here. Which one's the best one?
the top one.
Probably the top one's fine. So A is negative 1 plus B is 2 plus C equals 0. Sorry, this takes up so much room, it's hard to keep the camera up. So negative 1 plus 2, positive 1, we're going to subtract 1, C equals negative 1. So what are your partial fractions? So then we're going to go back to here. So remember this blue piece here, this is what we're looking at. So A over x plus 1. Can we do that here? We can barely see that all there together. These take a lot of paper, just pre-warning. Okay, so A is negative 1 over x plus 1 plus B is 2 over x minus 1 plus C is negative 1 over x plus 2. Those are your partial fractions. Okay? Now, that is what we call case number 1. There are going to be 3 more cases that we're going to do, and you're going to need to recognize those. This basic format is going to continue. There will be some tricks that you're going to need to be aware of. So, as far as my advice, if you want to start on section 3 homework, make sure that you only do the ones that have linear factors, because if they don't have linear factors, there's a trick, and I haven't showed you the trick yet. Okay? Or you can just wait and just do sections 1 and 2. You'll probably have plenty of time. But I knew that this will take a long time tomorrow, and I just kind of wanted to expose to you, this is a perfect example of why we do 3 equations, 3 unknowns. Yes?
Are you gonna have this long of a problem on like test?
Probably longer.
Really?
Are you being serious?
So when
I
we're
don't know, this is going to be a tough test. Huh?
when we're solving this, is this to solve for the intersection of that original equation?
Say it again.
Are we solving for the intersection of the original equation?
Solving for the
When
intersection.
when we find what the variables equal, what does that get information?
So yeah, the A, the B, and the C. So you're just going to put A over the first one, B over the second one, C over the third one.
And those are
So this is the answer I'm looking for right here.
those are the original equations.
So when I started with this fraction, 5x plus 7 over x cubed plus blah, 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 this is the answer I'm looking for. It's good, huh? And you're like, oh, give me back logarithms again, right?
It's just
All right.
super long. It's not like
It is
hard.
long. Yeah, it's long. Yeah. So see y'all tomorrow.